Alright, at this point in talking about light, it's time to focus in on some very specific applications of light refraction, specifically lenses, and thin converging lenses is what we're going to focus on in this course. So we're going to talk in this video first about just some basic terms and definitions, and then in a couple more videos we'll talk about some other things relating to lenses and how you can use them and apply these ideas and so on. Alright, so first we're going to talk about some terms. Alright, so what are we talking about? Well, what is a thin converging lens? Well, we have a couple options. I only put two pictures on here. There are other applications for these, such as using them in telescopes and things like that. Refracting telescopes. In any case, a magnifying lens is one example of a thin converging lens. This would be a monocle in olden times, and I believe that also is a converging lens, although it may be a bit of a complicated lens. In any case, for sure, a magnifying glass is a thin converging lens. Alright, so that's the idea of what we're talking about. And let's move on to some specific terms and definitions. Alright, the next slide is going to be a little bit busy, but I'll focus in on it and do one thing at a time. Alright, so here we go. Okay, so here we go. Bunch of different terms relating to the thin converging lens. So the actual lens is located here, and it's drawn in here with a central axis through the lens, and then this line that goes through the center of the lens as well. So first thing, where in this diagram, you'll see diagrams like this, although we usually don't draw in the actual lens. You'll see diagrams like this a lot when we're working through this part of the course. So let's start here. Alright, center of the lens. Where is that? Well, that's right there. Okay, right there, center of the lens. Alright. Better definition for the center of the lens involves this right here. The principal axis. Now the principal axis is defined as a straight axis that flows through the center of the lens, that goes through the center of the lens. Obviously, if you're looking at a lens, you cannot see the principal axis, but the principal axis would go straight smack through the exact center of the lens and continue on to the other side. Alright? Cool. Anytime we're talking about a lens, we're going to be talking about something that we see through the lens or something that is visible as a result of the lens, and that thing would be the object. Now, often, we're going to draw it in like this, alright? We're going to represent the object, whatever it might be. It might be a house, it might be a tree, it might be a person, whatever, but we represent the object with this vertical arrow, okay? And sometimes it might even be like a cardboard arrow or something, just sitting there. But in any case, we represent it visually with just this arrow, and then the tip of the arrow is considered to be the top of the object, right? The very top of the object, whatever it is. So we call this arrow actually is the object for the purposes of this diagram, okay? Well, then we have a term that relates to the object, and that's called the object distance. That's how far the object is away from the central plane of the lens. So this line that goes through the center of the lens here vertically. The distance from that line to the object would be the object distance. And then on the other side of the lens, as a result of the way that the light refracts through the lens, you're going to get an image that's formed, and you would be able to see this image on a screen. If I stuck a screen here, just a piece of paper or a more official screen like a projector screen or something, right here I'd be able to see an image of the object. Alright, we'll talk a lot more about that later, but in any case, so there's an image. And then of course, as you might guess, there's also the image distance, alright, which is how far the image is from the central plane of the lens, okay? So far we've got the principal axis right through the center. We have this central axis of the lens vertically. We have the center of the lens. We have the object distance and the object, and we have the image distance and the image. Just a couple more things to talk about, especially the principal focus, which is sometimes called the focal point, but it's more appropriate to call it the principal focus. So what is that? Well, the technical definition is that is the point at which a light ray passes through the principal axis after having been parallel to the principal axis. So what does that mean? Well, if you take a light ray that is going parallel to the principal axis, just like this, principal axis, light ray going parallel to it, passes through the lens, refracts once at the first surface, refracts a second time at the second surface, and then continues on its way. The point where that light ray crosses the principal axis, that is the principal focus. Of course, light rays can go both ways through this lens, so there's a principal focus on both sides, and that is the same exact distance from the center of the lens. So this is one distance, this is another distance, same distance, and there's a name for that distance. It's called the focal length of the lens. All right, F, the focal length. That is the distance from the central axis of the lens to the focal point or the principal focus. All right, so that distance is called the focal length. All right, and obviously there's a focal length on this side, and there's a focal length on this side. Now the last thing we have drawn in here on this diagram is these 3 red lines, and those represent 3 special light rays, and those are used in the next couple of videos. So we won't worry about them here, just know that they exist. We'll talk about them more later. Okay, so let's summarize what we've learned about light rays and lenses, thin converging lenses. Okay, so here's the main ideas. When light rays refract through a lens, they bend in very specific ways. All right, thin converging lens. So a ray of light that is passing parallel to the principal axis on one side of the lens will refract through the principal focus of the lens on the other side. Conversely, the opposite also happens. If a ray of light is passing through the principal focus on one side, when it refracts, the light ray will be parallel to the principal axis on the other side, all right, of the lens. Now, the lens itself will form an image of the object, but the properties of the image will vary. They'll be different depending on several different factors, and we will talk about those in another video. If we were to look back at the previous image, you would have seen that in the case shown in that diagram, the object was larger than the image, and it was upright, whereas the image was inverted, upside down. All right, so there you go. Those are the crucial key definitions and terms so that we can then start talking more about light rays passing through a thin converging lens and what happens with the image and how you can use those and all kinds of interesting things that you can do with that. All right, so that's all for this video. Thanks for watching, and we'll see you next time.